Hackers are always trying to peek into your data whenever you are online. Whenever you type a password, send a message, or buy something with your credit card. But here is the question: why can't they? So that little icon on your browser, the address bar, is actually shielding you from this kind of attacks. But what's really happening behind the scenes? It's not magic. It's big maths, numbers, secret keys, and an invisible handshake that turns your words into unreadable codes. Welcome guys back to the channel. Today we are going to uncover the hidden process of HTTPS, and trust me, once you see how it works, you will never look at the internet the same way again. On top of the OSI model is the application layer. And the application layer also is on top of the TCP IP model. That means that application layer is kind of important. The application layer serves as an intermediary between a computer user and the network he or she is connected to. So for you to send something through a network, you have to use the application layer to get that interface. You have to use an application. Without an application, you cannot use the network, or you cannot operate through the network. So the application layer gives us an interface that gives convenience to communicate through a network. So the application layer has been divided into its functionalities, its main functionalities, and one of its functions is to help transfer files from one location to another, or from one computer to another. So the application layer helps us to send information from our PC to another PC through files. And another function is it also helps you to connect remotely to servers that are not in your location, or servers that are not around your location, so you can work remotely. So if you are in Ghana, if you are in another country and you want to work in India, US, China, you can connect to a server in that location and you can work just as someone in the same location. So it helps us to remotely access server and do a lot of communication with the server. And it also helps us in sending emails. So if you are applying for a job, you are applying for an interview, you are applying for any kind of position, and you are required to send an email, is this application layer that gives you that interface that helps you to. So we will be talking much about the protocols, because if we understand the protocols, we understand what is used for, then we understand much about how information are communicated through the web. So we start from the key functionalities of the protocols. So the key functionalities of the protocols are: one, it helps in client-server communication. So we all know what a client-server is. And if you don't know, client-server is kind of communication protocol, communication architecture, whereby a client connects to a server. So a client connects to a server, which can be a local server, or a server that's not around, a remote server. So this is the server and this is the client. And what the client do is that the client requests for something from the server, and the server gives the client a response. So the client gives a request and the server gives a response. So that's how it works. So the architecture of the clients and the server is just basically that. So the client will give a request and the server will respond the client of its request. So that's how basically the client server architecture works. So they are saying that the HTTP follows that same architecture. The HTTP follows the same architecture, whereby if the user wants to access a website, to log into this browser and request for this website, and the server will provide the website to the client. And the second thing is that it helps in resource transference. So we know when it comes to websites, we use HTML to write websites, which means a hypertext markup language. So it's the language that we use when it comes to the web. Anything about web is HTML that we use. So we use it to transfer. So we use this protocol to help us to transfer these files. So whenever we want to send a file like HTML or website from a remote location to a local location, or from a local location to a remote location, we use this kind of protocols. And HTML, I think right now of late there have been a lot of frameworks that's built upon HTML, but HTML is still the fundamentals of all the web communication that occurs. So any website that will be seen, it has this HTML inside, and the CSS is used for styling, and JavaScript gives you functionalities. Right now we have one key, the last point, which says that stateless request response model. Stateless request response model. So when you talk about stateless is something without memory. Something without memory. So if something is stateless, that means that it has no memory. So if it has state, then that means that there's memory attached to the thing. So we have state and stateless. So stateless means that no memory. So what this is trying to say, that it says that request response model that are stateless. So let's see how it also looks like. So this is the same client server architecture we are using. So this is our server and this is our client. So when I request for something from my server, I do a request and the server responds to me. What the stateless is trying to say is that there's no storage of this kind of transaction. So no one stores this transaction anywhere. So it's like you meeting a stranger outside and greeting the stranger. By the end of the day, you will not remember the face of the stranger. The stranger too will not even remember you. That's how it works. So you just greet each other. No one the next day you can meet yourself, you can greet. Yes. So they don't keep any records about their transaction or their communication. So the client send a response and the server send the client send a request and the server sends what? A response. So that's how it basically works. So let's move to the next slide. So the next slide is talking much more about the HTTP. So the HTTP and the HTTPS, all of them are protocols that we use in web communication. But the reason why we have HTTP and HTTPS is that the HTTP and the HTTPS is differentiated by the S part of the HTTPS, which serves as a form of security. So this S is the only thing that is distinguishing the HTTPS from the HTTP. So it's serving as a. So I think the age of the internet, they had no concerns about security, because the web was being used for research purpose, and they were using it for like knowledge gaining and all the stuff. So there's no need for us to be much more concerned about research. But as time goes on, as people get to know much more about the web, a lot of evil people also join the web, and now you have to add security to all the protocols we built that we didn't add security to it. So you can see that some protocols were updated, others were being changed to another ones. Yes, all because they have to emphasize on security, because security has become an issue. So HTTP had no security in it, and it was fine. It works fine. But now we have to be cautious about someone who is called hacker sitting somewhere looking for us to exploit. So someone is there waiting for us to be loose, so that you get our information and get access to things that belongs to us. That person is the hacker. So right now, we know why we have the S in our HTTPS. So right now we are talking about the HTTP. We are talking about the HTTP. We're talking about the HTTP. So here he's saying that the HTTP uses port 80. And when it comes to networking, we talk about ports. Port is like openings. It's like a door that opens a window into the place that you can find HTTP. So if you are looking for HTTP and you are on the network, there's an opening that is named 80. So if you are looking for HTTP, you go straight to port 80. So port is like a tunnel that you route through to come and find HTTP. So if you are communicating through this protocol and you want to share files, you have to use a port, or you have to communicate through the port 80. You have to communicate through the port 80. So these are the characteristics of HTTP. So HTTP use port 80. All other protocols also have their own port. So the port gives you access to that protocol. Yes. And so another characteristics about the HTTP is it was transferring files in plain text. Plain text. So if I'm sending something to someone, so this is my computer again. Let's use the client server architecture. So this is my computer and this is my server. And I want to send something to someone. I want to send something to the server, my password. I'm logging into Amazon. I'm logging into Amazon with my name and my password. With my name and my password. I'm logging into Amazon to go and do online shopping. So I've sent my credentials to the server to authenticate me. How this process will go through is that when I enter my password and my username, the computer will convert it into zeros and ones. It converts it into zeros and ones and it transfers it to the server. Transfer it to a server, either through a wireless medium or a wired medium. So you can transfer it through a wireless medium or a wired medium. So if you are transferring something from your computer through a wireless medium, it's either you use the radio frequency, so you transmit it through a radio frequency. And if you are using a cable, which is the wired way, you use signals. So signals will be passing through to the server. But there is an issue to this kind of communication. The issue is that if you are sending something to someone using plain text, if I'm outside here, on my computer, trying to listen to what you are doing, I can go and buy something. If you are using a wireless medium, I can go and buy something we call the RF detector, radio frequency detector. So I'll hold it and I'll connect it to my PC. So I'll detect, or the computer only does that because it understands that language. So we have to encrypt it so that it can transfer it to the server. So it adds no form of security to it. So if the person here, the hacker, intercepts and gets the information, it will go to a website that converts binary patterns to JSON. Binary patterns to JSON. You will get all the information that you were transmitting. So that's how the HTTP was transferring data, of which it was vulnerable. Yes, because if anyone is standing here, it's like you standing on a story building and shouting to someone at the ground floor your password. So here is David and here is Amma, and Amma is saying that David, the password of my MacBook is 122. So the password of my MacBook is 122. And Daniel too is standing here. Daniel is not a thief. But because he knows your password, he can just pick your laptop, open it, and maybe Daniel might have interest in your laptop because it's MacBook. He's not a thief, but because it's have open access, and probably maybe you are not there, he can just take it and go and use it and bring it, or he will keep it forever. You won't know that Daniel is the one keeping your laptop. So that's how the HTTP was just doing. So anyone who was interested with your data, anyone who had small technical knowledge about eavesdropping could just stand in the middle and take your data, convert it, and use it for whatever you want to do. So mind you, this is actually your credential, your credit card information, and your password. The person can use your credit card information to actually buy something online, and it will be like you are the person buying it. So he can impersonate you and buy a lot of stuff, and it can cost you much. So that's why we have to do much more to help people not to go into these situations. So that's how it works. And the stateless protocol, we explained stateless in the last slide. And stateless actually means that the protocol does not keep anything in memory. It doesn't keep any information in memory. So if I do transaction and I do another transaction, that same transaction, there's nothing in the memory. It just deletes everything after the transaction. Everything's okay. It's like I've written you. That's it. I don't keep your name. I don't keep anything about you. I've just taken all that I wanted from you. I met you to deliver a package to you. You accept it. We all go on our separate ways. I don't need to remember your name. You don't need to remember mine. That's how it works. So stateless protocol, that means that we don't keep any memory about anything. And we have requests. We have how we can actually do our requests. When I was doing the illustration, I was talking much about request, client request, the client request. The client actually has ways it does its requests. And these are the methods. So for you to actually get something from a server. So if you want to request something from a server, you just use the get method. You want to send something to the server, you use the post method. And if you want to update something on the server, you use the put. And if you want to eliminate or delete something from the server, use the delete method. So these are the methods that we use when it comes to there are plenty, but these are the main ones that you might see in exams and everything. So let's talk much more about the vulnerability part of HTTP. So vulnerability part of HTTP, we know that right now our information is not safe because anyone can actually listen to, or anyone who is interested can actually get access to it. And we know that so this man in the middle is actually, so the eavesdropping was what I illustrated in the drawing, that someone can actually if the person is interested, he can just hear what you are trying to say because there's no covering around it, and get access to whatever he wants to get access to, or listening to whatever he wants to listen to. So that's the eavesdropping. I'm listening to your information. You think it maybe is secret, but I'm there having it. So it's like someone looking at you at the top, you at the down, you don't see the person. You thinking that no one is there. Yes, so you can do whatever you're doing, but someone is watching you. Yes, that's how it is. So eavesdropping, everyone can get access to whatever you are sending. And you have the man in the middle attack. The man in the middle attack is kind of different from the eavesdropping. So then what's the man in the middle attack? Or what the man in the middle does is he'll come and stand in the middle. I know someone want to buy something on Amazon. I'll come and stand in the middle. Someone will start logging in. So this is the server. Someone will start logging in. So once someone initiates the conversation, I'll come and start here and block the communication and respond to Samuel. And someone will think that I'm actually the server. So he will send all his credentials to me. His password, his credit card details, he send it to me. Then I take all this information and I'll use it for my devious means. So that's how it works. So the man in the middle is different from the eavesdropping. The eavesdropping is you don't block the communication. You are standing somewhere, but you can get access to the information. But the man in the middle come and impersonate the server. So you'll be thinking that you are sending something to the server, not knowing you are sending it to someone who wants to hack you. So it's kind of, yes, not safe. And you also have data tampering. So if someone gets access to your information, he can tamper with everything that you want to do. He can actually delete some, you can do whatever you want to do with it. And when it comes to authentication, there are no authentication attached to the HTTP. So if you want to go inside, no one questions you. No one will even talk. No one will even give a concern about it. So it's kind of more freedom. So you have the freedom to actually do whatever you want to do when it comes to the HTTP. So another core part of this is the HTTPS. So the HTTPS wanted to solve the issue that comes with the HTTP. So it was an upgrade, or it was also a new version of the HTTP to come and fix the vulnerabilities. So how does the HTTPS solve the issue of security when it comes to the HTTP? So the security part of it. So when it comes to security, we do a lot of stuff. So when it comes to security, there's one branch in computer science we call cryptography. Cryptography is the study of how we can actually safeguard our transmissions or our communication, such that no one can actually get, or no one can actually get to know much more or hack into our system. So cryptography is about ensuring safe communication. Cryptography, and out of cryptography you can get the word cryptic out of it. We can get the word cryptic out of cryptography. So cryptic. You can get the word cryptic out of cryptography. And cryptic actually means making something mysterious. Making something mysterious, or making something mysterious. Yes, so if you talk about mysterious, I mean making something unclear, making something unclear, making something random, making something meaningless, making something gibberish, like, yes, making something unuseful. Yes, so that's it. So cryptic, so that's the meaning of cryptic. So encryption comes in here. You can actually get encryption out of cryptic. So encryption means making a data mysterious. Making a data mysterious, or making an information mysterious. That's what encryption means. Making an information mysterious. So when it comes to encryption, we are trying to make a useful or meaningful information meaningless to anyone other than the receiver. We are trying to make a useful or meaningful information useless to any other person other than the user of the information, or the receiver of the information. So that's the intention about, or the intention for encryption. So encryption, we don't really do encryption. We have an encryption algorithm that helps us to encrypt our data. So a whole lot of task force sat down and they chose a well-designed algorithm that will help us to have a standardized encryption algorithm that we'll be using in our daily day-to-day activities. So the encryption algorithm they chose was the AES 256. This was the encryption algorithm they chose. So this encryption algorithm is actually a well-trained algorithm that gives us the encryption that we need. So when it comes to encryption, you have two main types. You have the symmetric encryption. When you say something is symmetric, that means that it's the same. Is the same, like something that's same. So when you say someone is symmetrical, so you can say human beings are symmetrical because when you divide human beings into two, you get two equal parts. So we are symmetrical. Yes. And here is trying to tell us that we using the same key. So for you to actually encrypt something, so let's think of encryption as I have this test, I love you. Making it gibberish. So that means that you have to randomize a whole lot of stuff. So you have to randomize a whole lot of stuff. So it takes more than this. There's more into encryption than this, but then this is like a small way for you to see how it works. So this is how the encryption is told. Right now, I love you have stand into this way. You will never get to understand what I'm trying to tell someone if you get to this information. It's useless to you. It's useless. It's useless. And encryption comes with a key. For you to actually encrypt, you have to have a key, because after the encryption, you have to know how you encrypted it so that you can actually decrypt it. Decrypting means that sending it back to its original form. So after doing it this way, then how to send it back to this way is decryption. So sending it back to its meaningful form is decryption. So decryption. So we encrypt, we decrypt. So we have to have a key. And it's this key that the symmetric encryption is saying that we use the same key to encrypt, and we use the same key to decrypt. We use the same key to encrypt, and we use the same key to what? Decrypt. So we also have so let's go on and know much more about the symmetric encryption. So we are saying the symmetric encryption is faster and efficient. It's faster. It's faster because it uses one key to actually open and close. It uses one key to open and close. Other than its counterpart that you use different keys to open and close. So we have a problem when it comes to encryption, which is symmetric in nature. We have a problem with it. And the problem is that whenever we are doing encryption and it's symmetric, because we are using the same key to unlock and open, if you have a client here and a server here, and you want to communicate with the server, and we are using symmetric encryption, we convert our password and username into binary. So we convert it into zeros and ones. Then after converting into zeros and ones, we encrypt it using the encryption algorithm with the key. So this is our key. This is our key. And this is our encrypted test. So we have a key and you have an encrypted test. So we send our encrypted test to the server. The hacker is sitting here. You can still get access to the message. But now the hacker don't understand the message because he does not have the key. So as the server too does not understand the message. Why? Because he does not have the key to open the message or decrypt the message. So right now it's like you have logged a message in a box and you have sent it to the server. The server does not have the key, does not have anything to open the safe or the box. So right now it becomes a problem. So for us to actually deal with symmetric encryption, we have to send the encrypted text and the key. So I have to send a key to who? The server here. So server have to have the key in order to actually open the code or the message I've given to me. So this is the key, and so right now the server can actually open the code and or open the text and read whatever is inside. But while sending the key, the hacker too is there. You can still eavesdrop, or you can still get access to your key. So right now, that means that there's no essence of we doing this, because if the hacker can get the key and get the message, then there's no essence for we doing the symmetric encryption. So there's vulnerability in symmetric encryption. If we would do the encryption, and for us to decrypt it, we have to send the key to the from like the same channel. We have to use the same channel to send the key. Then that means that there's no essence, because the hacker too can also get access to the key and also decrypt the message to like the meaningful message. So if I sent, if it was hello that I sent, he can also debug it to get hello. He too gets hello. So this makes the symmetric encryption unsafe. So right now we know the issue that comes with symmetric encryption. So the key exchange have vulnerabilities in it, attached to it. So that's what I indicated. So you exchange the key, if the person get access to the key, then that means that the person cannot get access to your message. So it makes it vulnerable. So let's move to the other part of it, which is the asymmetric encryption. So instead of using the same keys, right now asymmetric means that we are using different kind of keys. So right now we are using the public key to encrypt it, and we are using a private key to decrypt it. So the public key will help us to encrypt it, and the private key will help us to decrypt it. There's kind of confusion when it comes to the public key and the private key. Using the public keys, and one may ask, why are we using the public key to encrypt and we are using the private key to decrypt? There is always a relationship between the public key and the private key that we don't know. We don't know, but to the server or to the client, they know the relationship. So they know the relationship. So that's why they can use the public key to encrypt and use the private key to what? Decrypt. So they can use the public key to what? Encrypt, and use a private key to decrypt. But this is actually slow. It's like you're having two keys to open one door. One is to open it, and the other is for closing it. So as compared to the symmetric encryption, using one key and using two, you know how it works. So that means that this becomes more slower than the symmetric encryption. But the symmetric encryption too is vulnerable to insecurity. Is not safe because you'll be sharing the same key. So let's see how the asymmetric encryption works. So let's see how the asymmetric encryption works. So let's use the same diagram. So here becomes the client, and here becomes the server. So here becomes the server. So the server send the public key. So the server send the public key. So you send the public key to the client. So the server will send the public key to the client, and the client will use the server's public key to encrypt the message. To encrypt the message. Then you will send a message to the server. So right now the server has a public key being used to encrypt the message, and you also have a private key that you can use to decrypt the message. You have the private key. So the server will send its public key to the client. The server will send its public key to the client, and the client will use the server's public key to encrypt the message. And the server's public key, when it's used to encrypt a message, is only the server's private key that can be used to decrypt it. The server will use his private key to decrypt the message to hello. So it will use. So if there's a hacker here hiding somewhere here and want to get access to the information that you are transmitting, he will get access to the public key because you are transferring that and it's public. You get access to the public key and you get access to the message you are sending. The message you are sending, but he cannot get any meaning out of it. It becomes useless to the hacker. So that's what we are looking for. We are looking for an encryption that the server cannot decrypt. That's the essence of encryption. If you're able to encrypt and the only person that can actually decrypt is the receiver, the intended receiver, then that means that we have achieved our aim or our goal for encryption. Aside that, the encryption becomes useless. So right now, I think we are achieving that one. We are achieving that one by we deceiving the user to think that the public key can actually unlock the code. So the public key cannot actually unlock the code or the message. It cannot unlock the message. It's only the private key, which is at the server side, and we don't share the private key. We share only the public key, and we don't share the private key. So the private key becomes some secured password or passcode that helps us not to get ourselves vulnerable to the hacker. So that's how the asymmetric encryption works. So that's how the asymmetric encryption works. But then the asymmetric encryption does not even solve the issue, because let me show you one thing. If we have, it doesn't solve the issue. It doesn't solve the issue. So if we have this client here, we have the server here, and we are sending message from the client to the server. The hacker, instead of tapping into the message, he can come and stand here to pretend to be the server. And receive. So instead of you getting a public key from the server, the hacker give you his public key. The hacker will give you his public key, and you use that public key to do the encryption, and you send it to the hacker, thinking that the hacker is actually the server, which is the man in the middle attack. So this is called the man in the middle attack. So you think you are sending it to the server, not knowing you are actually establishing a connection with the hacker, and you will never know. Because you cannot track between you and the server. So right now he's giving you all the information that so you give him the acknowledgement. You send first an information like hello, he will respond hi, I want to establish connection with you, and he to respond, I'm ready for connection, this is my public key. And you actually do everything that you want to do with the server with him, thinking that he is a server, not knowing he's trying to deceive you to think that he is a server. So the man in the middle attack is a result of impersonation of the server. So the man or the hacker will actually impersonate the server for you to think that you are working with the server, not knowing you are actually working with a hacker. So that's how it works. So this becomes an issue. So we'll find a way to actually solve this issue. The asymmetric encryption is slow but secured. That one we know why it's secured. because we don't share the private key, we share the public key, and you can't use the public key to decrypt the code or the message. That's why it's actually secured. So for every connection to actually come on, they need to have a secured handshake. So the security part of the HTTPS does not only relies on the encryption, it also relies on the handshake done by both sides. So there will be a handshake by both sides to actually establish a connection. So that one too helps in the security part of it. So that one helps in the security part of it. So let's go in depth into the security, the handshake. So let's go in depth into the handshake. So we have a client here. So we have a client here. And we have a server. We have a client here, we have a server here. And for every device to actually communicate in the HTTPS, there have to be a handshake, the TCP handshake. And how does a handshake occurs? So there are 3-way handshake. So we have 3 main ways to actually do a handshake. So this is how we do a handshake. You connect to the server, giving a synchronization for a synchronization. So we call it sync. So you sync with the server. So we synchronize with the server to ask the server, hello server, can I actually have a secure communication with you? Then the server will respond back. Hello server. So before you can start any connection with HTTPS, after the encryption, before the encryption, you have to first do a handshake. So it's during the handshake that we exchange the public key. So you exchange the public key during the handshake. So you first send a sync message. The sync stands for synchronization. So you synchronize with the server, asking the server, hello server, please, I want to have a communication with you. Are you open for communication? Then the server also acknowledge your synchronization. So he synchronize you back, and he also acknowledge you. This is a TCP IP, the TCP handshake. This is a TCP handshake. So the server acknowledges you back and say, oh yeah, I'm ready for communication. I'm ready for secure communication. And this is my public key. You can call me, or this is my contact. You can call me on this one. So the server will send his public key and his detail. Then the client will acknowledge the server. Like, thank you very much, server, for being open for chat or being open for a connection. Then this is how the handshake works. So they all agreed on a specific protocols to use, specific IP suite to use, a specific algorithm to use, and everything to use during this handshake. So the handshake, so this is actually the reason why we call the TCP to be a connection-oriented protocol. So a connection-oriented protocol in the sense that before it can actually communicate with you, you have to first handshake with you. Yes, so you have to first have a handshake with you. Then you start the communication. So that's how it works. So this is how it actually goes. So the client will actually send a hello. So this is how the handshake goes. The client will send hello. So hello. So then he add a supported cipher, the cipher that the client supports. So the client will send a hello message. The client will send a hello message to the server, and he asks, hello server, this is the kind of encryption that I support, and he has a random number to the server. And the server too will open it and choose the cipher he want to deal with. So out of the supported ciphers, the server too will pick one and and add a random number to it plus a certificate. You reach the certificate right now. So plus a certificate, he sent it to the client. So the client receive the certificate chosen cipher plus a random number. So the client then go to the certification authority. So the certification authority, they give certificates to servers for the servers to be more accredited or more, yes, so it's like an accreditation for the servers. So the server actually send the certificate back to the client, and the client will see, oh yeah, the server actually has a certificate. So the client have to do his background check and see if the certificate is actually authentic. It's like you going for interview, sending your certificate, and the interviewer is actually checking if you actually went to University or you are just lying about that. So you call someone in University and ask, do you know this? You call your HOD. Hello HOD, please, do you know this name with this index number he completed this year? And HOD will check if he has this kind of record and give back some feedback. So the client check the CA signature to verify everything, and they exchange keys. So the exchange keys, so the pre-master secret encrypted, pre-master secret encrypted with a server public key. So the exchange key. So I think we'll get back to this one into more details. We'll talk much about the key. So they'll exchange key, and they will create a session key. A session key is actually, okay, let me talk much about it so that we can actually understand what a session key is. So they will exchange key. So we right now we know that there's ways of resending when it comes to keying. When we talk about keying in networking, most of the keys we talk about is encryption keys. So we have a server here, we have a client here. Right now we know that whenever we want to send something to the client, we use the client. If we want to send something to the server, we use the server's public key, and we encrypt. Use the server's public key, and we encrypt our data. So when we encrypt our data, then we send our data back to the server for the server to actually decrypt it with his private key. So with the private key, so he will send a public key to us, and we use it in addition to some random tests. Then we send this whole package back to him, the server to actually decrypt it. So if the server to want to actually send something to me, he will to have to take my public key and encrypt it with a test and send it to me, so that I'll use my private key to decrypt it. But this process is a process that is actually tedious. We don't use this process because it's time consuming and it will take a lot of time, because at the time we always have to do some exchange, and it costs it wastes time. It wastes CPU time, it wastes a lot of time, resources. So there is a new way, and right now we know that symmetric encryption is faster than asymmetric encryption. So we find ways of making the exchange more faster and more reliable and secure. So how do we do this? So because I know his public key, I will encrypt his public key with a random key. random key, which we call the premaster secret. Random key, which we call the premaster what? Secret. Call the premaster what? Secret. So this premaster secret will be encrypted with the public key. So I pick a random key, which will be the premaster secret, and I'll encrypt it with the public key that the server sent me. So the server will send me a public key, and I'll use it to encrypt this one as the message. So this one, the message I'm sending to the server will be a key. So I'll send this key to the server. So when the server receive this key or receive this message, the server will decrypt the message with the private key that he has. And after that, we will all have a common key, which will be a symmetric key that is common between us, that anyone does not have access to. So if someone is here, what he will get is the public key plus the message, which has been encrypted. The public key encrypted in the message. That's what he will get. And when he gets that, he cannot decrypt it because he doesn't have the private key. So the hacker cannot use the information. The information becomes useless to the hacker. And right now, we are able to have a common key that will be between me and the server. So right now, we have a premaster secret key that we'll be sharing. So right now, we are no longer using asymmetric encryption to encrypt our text. We are using symmetric encryption with the help of this key. So this one becomes our session key that we'll be using. So the premaster key becomes the key that we'll be using. The premaster key becomes the key that we'll be using because the symmetric key offers speed or faster way of communication. We have to find a way of using the symmetric encryption. So right now we'll be using symmetric encryption other than asymmetric encryption. So we use only asymmetric encryption when we want to establish the connection. So we use the symmetric encryption to send the text, and after getting the text, we use the symmetric encryption, which will be the premaster key. After using the premaster key to be the actual session key that we'll be using to exchange information. So we'll be using this one same thing to encrypt the message, send it to the site. Because we all have the same key, we can decrypt it and encrypt it. And this key, no one knows it. It's between me and the client. So it's between the server and the client. So we have the premaster secret key. That will be the new session key that we'll be using for the symmetric encryption. So that's the key that he's talking about. So the premaster secret key. So the premaster secret encrypts with server public key. Yes, so they encrypt the premaster secret key with the server's public key, and both compute a symmetric key from a random value. So they both compute a symmetric key from a random value. So after they getting the premaster symmetric key, which has become a common key among them, they use the premaster secret key to generate a random. They add a random value to it. So right now they all have this one. They add a random value to it to make it more random. Yes, so they all add random value to it and use it as the session key. So this is the premaster. This is the premaster secret key. The premaster secret key, and we use it to actually do everything. So then we have a secure channel where we can actually use symmetric encryption to begin and do our communication, everything that we are doing. So that's how it works for the handshake. So this is all about the handshake. So we start from the hello message, takes the cipher, we choose certificate, verify the certificate, we exchange keys, we pick one, we all have one common key, which is the premaster secret. We add random values to it to form a session key, and we use it for a secured channel symmetric encryption communication. That's how it works. So right now we have certification authority. So the certification authority comes in to help us be more secured. The certification authority comes in for us to be more secured. So let's go back to our diagram. Let's go back. So right now we are at C, certificate authorities or certificate authority. So then there are authorities that are assigned certificate for web communication. And for us to understand this CAs, we have to actually go back and check 1 or 2 about our symmetric encryption. We have to check our encryption again to actually get what the CA is actually doing when it comes to the network security. So right now we have our client and we have a server, and now we know that whenever we are doing a transaction, we first do a handshake, and the handshake, the server will send a public key. During the handshake, the server will send a public key, and with a public key, the client will add a master secret to the public key and send it to the server for the server to decrypt it, and the server will have the pre-master secret too. So the server too have the pre-master secret. After decrypting the message, the server will have a pre-master secret plus a random number, and this will form the session key. This will form the session key. This will form the session key between the client and the server, and it becomes a secret key between both of them. But right now, this does not solve the issue of security when it comes to web communication. Why am I saying that? The reason why I'm saying this is because an attacker who happens to be in the middle of the communication can actually impersonate the server. So instead of you receiving a public key from the server, you actually receive a public key from the attacker, who happens to be the man in the middle. So the attacker or the hacker will actually come in between you and the server. So it will come between you and the server. And will pretend to be the server and give you the public key, and you will send, instead of you sending it to the client, you send him the pre-master secret. Send the pre-master secret plus his public key. You send this to the hacker. And what happens when you send this to the hacker? The hacker now becomes more comfortable because right now he has the key that he needs to actually do the transmission. So the hacker gets the key and everything that he needs to do the transmission. So right now the server has a pre-master key. The hacker too have a pre-master key. You all have a pre-master key. The server is not part of the communication again because right now you think the server is actually the hacker. You think the hacker is the server. Or you think the hacker is the server. So you'll be communicating with the hacker. And this is 100% possible. This is very, very possible because he can tap into your network, get access to your resources, convert it, impersonate the server, and get access to your pre-master secret, which becomes a secret key between you and the hacker. So right now you can send information to the hacker can decrypt it. So we have to find a way to solve this issue. And how can we solve this issue? The only way we can actually solve this issue is that we have to know who is actually the server. We don't have to be always deceived and be sending our information to the hacker. So we have to find a way we can actually know who we are talking to or who we are communicating with. So the hacker now is here, and we know the hacker now can impersonate the server. So what can we actually do to solve this issue? So that's when the CA comes in. So the CA will come in and will accredit the server, or will give the server a digital signature. When you say a digital signature, is like a key to show that yes, I've recognized you as a server. And how does this thing happen? So the server will send its public key to the CA, the certification authority, and the certification authority will add its private key to the server's public key and take information about the server to check the server's if the server is actually who he is saying he is. So he will take all the information about the server, and he will take the public key of the server. He will take the public key of the server plus his private key. So he add his private key and the server's public key to get a unique key, which becomes a digital signature, between the CA and the server, the certification authority and the server. So right now, instead of the server sending his public key, the CA will send the digital signature to the server. So you send the digital signature to the server, and the server will send it directly to the client. So the server will send it directly to the client. And right now, what the client will do is that the client will just go, because the CAs are actually selected and they are known by the browsers. The browser will go directly to the CA and check if the information that the server is providing is accurate and is actually from the original CA. To check if the information is accurate and to check whether it's from the CA the server is saying is from. So if it's from that CA, the browser will request for the key from the CA. So the browser will ask for the CA's key, and the CA's key together with the public key, the client can decrypt the key to actually get the public key of the server. So the private key of the CA will be given to the browser, and out of it, the browser can actually remove the server's key, public key, from the digital signature. You know, the digital signature has a key in it. The key comprises of the public key of the server and the key of the digital signature. Right now, the client has the private key of the digital signature. So now he can actually decrypt it and get the public key of the server. So when he gets the public key of the server, then he knows yes, right now I'm talking to the right person. I'm communicating to the right source. So then there can be a communication. So then if the hacker wants to actually come inside, he has to have a digital certificate, and it's difficult for the hacker to get a digital certificate. So what the hacker will do is he will just enforce himself. And even if the hacker is able to get the digital certificate will actually not be from only one CA. The digital certificate will be from a lot of CAs. So there will be a lot of intermediates. So before you actually get to the root or the main data or CA, before you get to the main CA, there will be a lot of intermediates here. So there will be another CA here. It will be from this one. another CA, another CA. So there will be a lot of CAs. So for you to get into the root CA, that means that you have to get a lot of permissions. And that's how they all do. So this one exchange is public key with this one, and this one exchange is public key with this one to add to this one add the public key of this one to this one to add. So it forms a chain. So we call it the certification chain, so the CA root chain. So for you to actually get to the root of the CA, you have to pass through all the chain, and it makes it more difficult. It makes it more difficult for you to get that up to the CA to get the certification. So this creates like a strong digital signature that the server will use to communicate his public key to the client. So when the client gets the public key of the server, then that means that he knows that, oh, now I'm talking to the right person, so we can start any communication. So right now, when someone like the hacker try and come in, he knows that no, you are not the right person. So the man in the middle can no longer be in the middle, because right now we know who we are talking to. We know the original source. So it was because we didn't know the original source, that's why the man was in the middle. So right now we have been able to break the barrier, and we know who we are talking to. So the man in the middle attack cannot work if we have a CA. So the issue of we getting someone in the middle to block us, to impersonate the server, has been resolved because of the CA. So that's why the CA is important. So the CA completes the whole security chain. So right now the HTTPS become more secure with the security, the certification authority, and it all comes together to make it more secure, to form the security we are talking about in the web communication. So right now we have a secured way of communicating, knowing that whatever we do, there's no one who can actually get to know what we are doing. So when you come here, you say that the chain of trust. So the chain of trust was what I was talking about. So there will be a lot of CAs, there will be a lot of intermediate CAs. So the root CA signs a signature. He will be the last person to actually sign, and he signs the signature himself. So a self-signed. So he will sign his own signature, and the root will come and issue a signature to an intermediate. So there can be about 15 intermediates, 10 intermediates. So the root will just give them the signature. So the server certificate is issued. The server also get its certificate. So the server will also communicate through the intermediates. So you also get a digital signature. So you get a digital signature from the issued by the intermediate. So the intermediate will issue a digital signature to the server, and the intermediate to signature is issued by the root, and the root issued its own signature. So that means that this is the root. So the root is looking to the intermediate. So this is the root. The root is watching over the intermediate. The intermediate too is watching over the server certificate. Then the server also send a certificate to the browser, which will be the client in the other end. And the client will also check. So from like how the process or the flow is going from the server, check the server certificate, then go and check the intermediate certificate, then go and check the root certificate for the key, and so that means that you will decrypt it using that same rule. So after decrypting it, you will get the public key of the server. You got the public key of the server. Getting the public key of the server, now they can actually now start the communication without fearing, without thinking about any hacker, without thinking about any person in the middle. So this is what the certificate contains. So it contains the domain name. The domain name is inside the certificate, the organizational information, the public key, the issuer signature, and validity period. So the certificate that we issue to the server is for a period of time. It's for a period of time so that it will be more secure. Because if anyone get access to the certificate, that means that we can actually get out of the encryption and we can decrypt stuff. Yeah, so it's given for a particular period of time. If the time elapsed, then you have to renew your certificate. Then you have to go back. So that's how it works. That's how it works. So that's it for networking, HTTP, HTTPS. We will continue on other time and we will look into other protocols. So thank you very much.